Okay, we're rolling. This is LR4, Unit 14, Lesson 1. We're going to talk about shortcuts of congruence. Okay, so if I say that triangle cat is congruent to triangle dog, there's 6 things that are true. 3 of those are angles that are congruent. Can you name a pair? Angle what? Angle C with angle what? D, sure. Right, first letter, angle C and angle D. Then angle A with what? O and T with G. Good. Perfect. It's 3 congruent angles if these 2 triangles are congruent. Okay, what else can we say? Well, side length CA would be congruent to what? DO. Good. But OD is not. Those aren't oriented the same way. So CA is congruent to DO. How about AT? OG and TC? GD. Good. So there's 6 items. If 2 triangles are congruent, there's 6 items that we could confirm are true. 3 congruent sides, 3 congruent angles. However, I don't want to do 6 things for each given problem. I only want to have to do 3 because we will require you to do 3 in order to prove congruence. Similarity, we could just prove 2, right? If I had 2 angles that were congruent, I could say that 2 triangles are similar. But if I have 2 angles that are congruent, I can't say that the triangles are congruent. All I can say is that they're similar. So let's move on to our first conjecture, which is the side-side-side congruence conjecture. I think we can all agree that looking at these triangles here, I think we can agree that they would be the same size and shape, congruent, right? Agreed? Okay, so that one is handed to you. That is like free chicken on your plate. You didn't even have to pay for it. You went to the ground round and they were like, hey, it's free chicken on Wednesdays. You're like, thanks. Does it come with, like a protein crust on it? They're like, no, it's already got like 24 grams of protein in one chicken breast, so you should be okay. Yeah, lots of protein. So if we look at the conjecture, if 3 sides of one triangle are congruent to 3 sides of another, then lasagna, right? Those 2 triangles are congruent. Okay, now, could this ever be the case where we don't have the 3 sides? Well, let's look at another example. Are those 2 triangles congruent? Based on what we just said? No? I say yes. Because Pythagorean theorem, if I use Pythagorean theorem on this one, 9 squared plus, let's call this x. X squared would equal 15 squared. 9 squared is 81. 15 squared is 225. If I subtract, oh, look at that. What does x equal? 12. Oh, snipe, snipe. So if I did Pythagorean theorem over here, what would that side be? 9. Therefore, yes, they are congruent by side, side, side via the Pythagorean theorem. Right, I had to use the Pythagorean theorem in order to show that it had side, side, side congruence.
Is there a way to do it without doing that?
There is. There's other shortcuts, and we'll get to those. On this particular one, you don't know right triangle trig yet, but you could. You could figure it out using that. Okay, so let's move forward. Our second conjecture, I forgot to erase this, is side angle side conjecture. So if I know 2 sides that are congruent, and the angle between them, that's what included means, the angle between them is congruent, then we have congruent triangles. So let's see what that means. So can we determine that these 2 angles are congruent based on their markings? Yes or no? Oh, okay, maybe it's not clear enough. Can I do that now? Can I say that those 2 angles are congruent in measure? Sure, okay. 41 is congruent to 41, and 52 is congruent to 52. Why am I putting an S there? Because those are sides. I have 2 pair of congruent sides, and the angles between them, the included angles, about to highlight the included angles. Included angles are angles between the given sides. Right? Would this angle right here be an included angle for those 2 sides? No. That's not an included angle because it's not between the 2 sides. So because I have side angle side, oops, let's go back for a second. Because I have side angle side congruence, then yes, those two triangles are congruent. So far, are we pretty good? Okay. Do we have side angle side congruence here? Yes, we do. What? How do I know that these two angles are congruent?
The 16, 16, and 10 and 10.
That doesn't tell me anything about these two angles. It's between. Okay, just because two angles are between doesn't make that. What is the definition of these two angles? They are congruent. Vertical angles make those two angles congruent. Vertical angles make those congruent. Therefore, I have a side congruent to a side, another side congruent to another side, and the angles in between them. So I have side angle side, which is a congruence conjecture that we just talked about, via vertical angles. I have used vertical angles to show that I have side angle side congruence. Okay, on this diagram, would these two triangles be congruent? Okay, would you agree that these are vertical angles? Okay. Do we have this, which was our first conjecture? No, because I don't know the side lengths here, right? So side, side, side is out. Do I know this? No. What do you mean, no? Well, I have a side and a side, and then I have an angle. I don't have the angle between the two sides. I don't have the included angle. Therefore, we don't know for sure if those would be congruent. Okay, let's get this across right now. Does that kind of look like a swear word? Yeah?
Yeah.
Yeah. Right? There's no swearing in this class. Side-side angle is not a congruence conjecture. Not. Yeah, backwards donkey. It's a donkey walking down the street backwards. Okay, we all good with that? So I have to have the included angle. That means the angle between those two sides. Okay, so that brings me to this. Here is the case that doesn't work. Side-side angle doesn't work. Here's an example of that. Notice that I've kept those two sides the same in the blue triangle up here and the red triangle below. So the angle and the two sides haven't changed, but the triangle has changed entirely. All right? So side-side angle doesn't always work. It's called the ambiguous case. If you make it to pre-calc and calc, you'll see that on a number of occasions. Okay, cool. Let's keep moving. So as I look at this, what do I know about AB? What is it congruent to? Not BD. DB, good. DB, okay. How about angle ABC? What is that congruent to? DBC, good. I like it. I like it. Okay, now here's something kind of sneaky. What is BC congruent to? Itself. What? That's called the reflexive property. Check this out. I'm about to do something technologically awesome. Oh, snipe. Right? I've got two sides, side, side, with an angle, congruent angle in between. So this is, I've almost done a two-column proof right now. We've almost done it. This right here, you guys, this piece, it was given. Well, duh. So I have a side congruent to a side. This piece right here, well, wasn't that given too? It was already marked that way. Yeah, so I have an angle congruent. What about this piece? Was it given? Kind of, but what did I use to get it? What property? The reflexive property. Reflexive, what does that mean? Well, if you use an object, an angle or a side, in both images, then you've used the reflexive property. If you use it twice, right? So I've shown that I have side, angle, side congruence. So we could say triangle ABC is congruent to triangle DBC by side, angle, side. That's a two-column proof. Done. You just did your first proof. How'd it feel? It'll look much prettier later. We'll do more if it didn't make sense. Okay, here's another case of the reflexive property taking place. If I drag one of these out of the other one, oh, look at that. Are these two triangles congruent? Yeah, by what conjecture? What shortcut? Yeah, side, angle, side. Good. Good, I got side, angle, side. Side, angle, side. Good. Okay, let's keep rolling. I think we're doing all right. I want you to take 2 minutes, talk to a neighbor, and determine whether or not, okay, so that's two examples here. I want you to determine whether or not the two triangles in problem 1 are congruent, and then the two triangles in problem 2 are congruent. And if they are, use the shortcut, either side, 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 or side, angle, side. So take 2 minutes, and we'll see how you do. We join forces. Let's do it. First one, yes or no? Yes, right? I see angles here that are vertical angles, so I see side, angle, side. I see yes. Let's see if when I uncover this, it works. Yes. Okay, good. How about the next one? The answer is no. These are vertical angles, but this is side, side angle. Side, side angle is not a shortcut, right? The only way that would work is if, let's say, these were marked the same. Then I would have side, angle, side, because you'd have the included angle between those two sides. So the answer to that one is negative, Ghost Rider. The pattern is full. Okay, let's see another example. Oh, no. Shoot. This is supposed to be oriented like this, and I failed. And the answer is uncovered. That's great. Perfect. Okay, so this is going to be recorded for those on the tube that are watching. But do you see the reflexive property happening here? Yeah? Oh, gosh. No, it's not. That's great. Okay, so I'm just going to sketch them out here. So I'm going to sketch PSM. Okay, and it looks to me like I've got that. Are the markings okay to you? And I've got RMS markings. Ooh, you know what? I think this answer is wrong. I think that answer is wrong. And I think the markings changed on me. Oh, they did. Okay, but whatever. I'll deal with it. It's all good. What could I say? What could I say about these angles here? Well, hold on. Pause. What kind of triangle is this? Isosceles. What's true about these two angles, M and R? They have to be congruent in isosceles triangle. So same thing has to be true over here. So what has to be true about these two angles? They have to be congruent as well. Okay, so I have side, I have angle, I have side, I have side, I have angle, I have side. Looks like yes, they are. By side, angle, side. Okay, this problem wasn't originally intended to go that way, but it's okay. Yeah.
So isn't the middle one supposed to be one line?
It is. And I'm just going off of what it looks like for those on the web, because if they just watch this, if you're watching, I'm going to go with that is congruent just because it looks that way right now in the video. So just follow along, kids on the web. Deal with it. Okay? On yours, though, it only has one line, right? Then we wouldn't be able to do that. Okay, we wouldn't be able to do that. All right. So just in review here, you guys, side, side angle, side are thumbs up. I'm gonna try to draw a thumbs up with a little bit of hair on the knuckles, and then thumbs down. Wow, that's a really small thumb. And this person, they have a lot of freckles, apparently. Okay, so side angle is no good. Tomorrow we're going to talk about angle. That's no good either. No car insurance, no swearing. Okay? You won't be told that many times in life, but no car insurance. At least the car insurance piece. Okay, so like, subscribe, comment below. Hopefully this went well for you. This time through, you guys, this unit, we're going to do homework on Schoology for reasons that you'll see as you do it. So good luck and good night.